Hello everyone, welcome in the solution session of exercise 7.2. In this exercise, we are going to learn about the change of variable. Let's try to solve first example. I is equal to integration of 2x upon 1 plus x square. As you can see here, we cannot integrate with respect to x. So let's try to change the variable. 2x is the differentiation of x square and 1 is linear combination with it. So let's take 1 plus x square as a new variable t. Differentiate both the side with respect to x. So differentiation of 1 will be 0. Differentiation of x square will be 2x is equal to differentiation of t will be dt by dx. So here we can say 2x dx can be rewrite as dt. So we can modify our integration in terms of t. Instead of 2x dx, we can write down dt, and 1 upon 1 plus x square can be rewrite as 1 upon t. So here we get one simple integration. Integration of 1 by t is simply log t plus c, and to get the final answer, just substitute the value of t, which is 1 plus x square. So this is your final answer. Ta-da! Here we have to integrate log x the whole square upon x dot dx. Here we have differentiation of log x within the multiplication of dx. So let's assume log x is equal to t. Differentiate both the side, we will get 1 upon x dot dx is equal to dt. So we are ready to modify our integration. Instead of log x the whole square, we have to write down t square, and instead of dx by x, we can write down dt. And to integrate t square, we have to use formula of x raised to n. So its integration will be t raised to 2 plus 1 upon 2 plus 1 plus c. To get the final answer, just substitute the value of t, which is log x cube upon 3 plus c. Ta-da! Here we have to integrate 1 upon x plus log x dot dx. Here from denominator we can take 1 upon x common. So we'll get 1 plus log x dot dx. So as you can see, the differentiation of log x, or we can say 1 by x, is within the multiplication of dx, as well as we have 1 plus log x. So let's assume 1 plus log x as a new variable t. Differentiate both the side. Differentiation of 1 will be 0 and differentiation of log x will be 1 upon x dot dx is equal to dt. So we are ready to modify our integration. Integration of 1 upon 1 plus log x will become your t, and 1 upon x dot dx will be your dt. So we are ready to integrate 1 upon t. Integration of 1 upon t is simply log mod t plus c. To get the final answer, you just have to substitute the value of t, which is 1 plus log x plus c. Ta-da! Here we have to integrate sin x into sine of cos x. Here cos x is your inner function, and its differentiation is also available within the multiplication of dx. So it's indicate that we have to assume cos x is equal to t. Differentiate both the side, we will get minus sin x dot dx is equal to dt, or we can say sin x dx is simply minus dt. So we are ready to modify our integration. This sine of cos x will become sin t into this sin x dx will become your minus t. So you don't have to worry about this negative sign. Just integrate sin t. Integration of sine t is simply minus cos t plus c. So this minus minus will become plus, and to get the final answer, just substitute the value of t, which is cos x. So cos of cos x plus c is your final answer. Ta-da! In this question, we have to integrate sin ax plus b into cos ax plus b. As you can see, differentiation of sine is available in terms of cos, and differentiation of cos is also available in terms of sine. So we can assume any one of them. Let's take sin ax plus b as a new variable. So your answer will be in terms of sine. If you take cos ax plus b as a new variable, then your answer will be in terms of cos. Now, let's follow the procedure. Differentiation of sine will be cos ax plus b dot a dx is equal to differentiation of t will be dt. So we are ready to modify our integration. Instead of sin ax plus b, we have to write down t, and this cos ax plus b dot dx will be dt by a. 1 upon a is constant, take it outside. We just have to integrate t. So our 1 upon a will be as it is, integration of t raised to 1 will be t raised to 1 plus 1, or we can say t square by 2 plus c. Now to get the final answer, we just have to substitute the value of t, which is sin ax plus b, the whole square by 2 plus c. So this is your final answer. Ta-da! Here we have to integrate x under root of 1 plus 2x square. So here 1 plus 2x square is your inner function, as well as its differentiation can be adjusted within the multiplication of dx. So let's say 1 plus 2x square as your new variable t. Now differentiate both the side. बोल सुमल से differentiation of 1 will be 0 plus 2 as it is. Differentiation of x square will be 2x dot dx will be equal to dt, or we can say x dot dx will be 1 upon 4 dot dt. So we are ready to modify our integration. Under root of 1 plus 2x square will become your t, and x dot dx will be dt by 4. So we don't have to worry about this 1 by 4, just integrate root t, or we can say t raised to 1 by 2. 1 by 4 as it is, integration of t raised to 1 by 2 is simply t raised to 1 by 2 plus 1, or we can say 3 by 2 by 3 by 2 plus c. So it can be further simplified as 2 2s are 4 and 3 2s are 6. Substitute the value of t, which is 1 plus 2x square whole raised to 3 by 2 plus c is your final answer. Ta-da! In this question, we have to integrate 4x plus 2 under root of x square plus x plus 1. Your x square plus x plus 1 is the inner function. So let's assume x square plus x plus 1 as your t. Now differentiate both the sides. Differentiation of x square will be 2x plus differentiation of x will be 1 plus 0 dot dx is equal to dt. Now let's rearrange the term under root of x square plus x plus 1, and let's take 2 common. So here we'll get 2x plus 1 dot dx. Now we are ready to modify integration. This 2 is constant, we don't have to worry about it. Under root of, instead of x square plus x plus 1, we just have to substitute t, and this 2x plus 1 dot dx will become your dt. So here we just have to integrate under root of t, or we can say t raised to 1 by 2. So let's take 2 as it is, and integration of t raised to 1 by 2 is simply t raised to 3 by 2 upon 3 by 2 plus c. So it will be 4 by 3, and the value of t is x square plus x plus 1 whole raised to 3 by 2 plus c. This is your final answer. Ta-da! Here we have to integrate 1 upon x log x raised to n. Here log x is your inner function. So let's assume log x equal to t, and its differentiation is 1 upon x dot dx is equal to dt. So we are ready to modify our integration. 1 upon log x will become t raised to m, and 1 upon x dot dx will become your dt, or we can say we just have to integrate t raised to minus m. So let's use integration of x raised to n. Here we get t raised to minus m plus 1 upon minus m plus 1 plus c. And to get the final answer, we just have to substitute the value of t, which is log x whole raised to 1 minus m upon 1 minus m plus c. Ta-da! Here we have to integrate x upon 9 minus 4x square. Order of numerator is 1 and order of denominator is 2. So here order of numerator is less than order of denominator. So we have to assume denominator as a new variable, or we can say 9 minus 4x square is t. Now let's differentiate both the side. Differentiation of 9 is 0. 4 will be as it is. Differentiation of x square will be 2x dot dx will be dt. Or we can say x dot dx is simply minus 1 by 8 dot dt. So we are ready to modify our integration. Instead of x dot dx, we can write down 1 upon 8 dot dt, and 1 upon 9 minus 4x square will become your t. So we don't have to worry about this 1 by 8. We just have to integrate 1 upon t, which is log mod t plus c. And to get the final answer, just substitute the value of t, which is 9 minus 4x square plus c. Ta-da! Here we have to integrate x upon e raised to x square. Here x square is your inner function, and its differentiation can be set within the multiplication of dx. So let's assume x square is equal to t. Differentiate both the sides, we will get 2x dot dx is equal to dt, or we can say x dx is 1 upon 2 dot dt. So we are ready to modify our integration. Instead of x dot dx, we can write down 1 upon 2 dot dt, and 1 upon e raised to x square will become t. So we don't have to worry about 1 upon 2. Integration of e raised to minus t. Integration of e raised to minus t is simply e raised to minus t upon coefficient of t, which is minus 1 plus c. So here we'll get minus 1 by 2, 1 upon e raised to, instead of t we just have to place x square plus c. Is your final answer. Ta-da! Here we have to integrate e raised to tan inverse x upon 1 plus x square. Here tan inverse x is your inner function, and its differentiation is also available within the multiplication of dx, which suggests that we have to assume tan inverse x is equal to t. Let's differentiate both the sides. We will get 1 upon 1 plus x square dot dx is equal to dt. So we are ready to modify our integration. His e raised to tan inverse x will become t, and 1 upon x square dot dx will become dt. Integration of t is simply e raised to t plus c. To get the final answer, just substitute the value of t, which is tan inverse x plus c. Ta-da! Here we have to integrate sine inverse x upon under root of 1 minus x square. Here, differentiation of sine inverse x is available within the multiplication of dx. So, let's assume sine inverse x is equal to t. Differentiation of sine inverse x will be 1 upon under root of 1 minus x square dot dx will give us dt. So, we just have to modify the integration. Instead of sine inverse x, we will write down t, and this 1 upon under root of 1 minus x square dot dx will become your dt. So we are ready to integrate t raised to 1. Integration of t raised to 1 is t raised to 1 plus 1, or we can say 2 by 2 plus c. And to get the final answer, just substitute the value of t, which is sine inverse x. So sine inverse x the whole square by 2 plus c is your final answer. Ta-da! Here we have to integrate 1 upon cos square x into 1 minus tan x the whole square. 1 minus tan x is your inner function. So let's assume 1 minus tan x is equal to t. Differentiated, differentiation of 1 will be 0 minus differentiation of tan x will be sec square x dot dx will be dt, or we can say sec square x dot dx will be your minus dt. So let's rearrange the terms so we can modify in terms of t. This 1 upon cos square x can be rewrite as sec square x dot dx upon 1 minus tan x the whole square will be as it is. So we are ready to modify our integration. This sec square x dot dx will become dt, and 1 upon, instead of 1 minus tan x, we just have to place t whole square will be as it is. So here we have to integrate t raised to minus 2, which will be t raised to minus 2 plus 1, or we can say minus 1 upon minus 1. So we just have to place the value of t, which is 1 minus tan x plus c. 1 upon 1 minus tan x plus c is your final answer. Ta-da! Here we have to integrate cos root x upon root x. Root x is your inner function, and its differentiation is also available within the multiplication of dx. So let's say root x is equal to t. So we can say 1 upon 2 root x dot dx is dt, or 1 upon root x dot dx will be 2 dt. So we are ready to modify our integration. Cos root x will become cos t, and this dx upon root x will become 2 dt. Here your 2 will be as it is, and integration of cos t is simply sin t plus c. To get the final answer, just substitute the value of t, which is root x. So 2 sin root x plus c is your final answer. Ta-da! Here we have to integrate under root of sin 2x into cos 2x. Here sin 2x is your inner function, and its differentiation is also available within the multiplication of dx. So let's assume sin 2x equal to t. Differentiate on both sides, you will get differentiation of sin box will be cos box into differentiation of 2x will be 2 dot dx will be dt. or we can say cos 2x dot dx is equal to 1 by 2 dot dt. So we are ready to modify our integration. Under root of sin 2x will become under root of t, and this cos 2x dot dx will become 1 upon 2 dot dt. So we can say this 1 by 2, take it outside, integration of root t, or we can say t raised to 1 by 2. So 1 by 2 as it is, integration of t raised to 1 by 2 is simply t raised to 3 by 2 upon 3 by 2 plus c. In further simplification, we can say 2 cancel out, 1 upon 3, substitute the value of t, which is sin 2x raised to 3 by 2. So 1 by 3 sin 2x raised to 3 by 2 plus c is your final answer. Ta-da! Integration of cos x upon under root of 1 plus sin x. 1 plus sin x is your inner function. So let's assume 1 plus sin x is equal to t. Differentiated, we'll get 0 plus differentiation of sin x will be cos x dot dx. This will give us dt. So we are ready to modify our integration. This cos x dot dx will become dt, and 1 upon under root of 1 plus sin x will become under root of t. Or we can say we just have to integrate t raised to minus 1 by 2. So its integration will be t raised to minus 1 by 2 plus 1, or we can say 1 by 2 by 1 by 2 plus c. Just substitute the value of t, which is 1 plus sin x, and 1 plus sin x raised to 1 by 2 plus c is your final answer. Ta-da! Here we have to integrate cot x dot log sin x, and cot x is the differentiation of log sin x. So let's assume log sin x is equal to t. So to differentiate this term, we have to assume box around the sin x. So differentiation of log box will be 1 upon box into d by dx of box. Within the box we have sin x, so differentiation of sin x will be cos x dot dx will be your dt. So here we can say cos x upon sin x will become cot x dot dx will give us dt. So we can easily modify our integration, as this log x sin x will be your t, and cot x dot dx will become your dt. Or we can say we just have to integrate t raised to 1, which is t raised to 1 plus 1, or we can say 2 by 2. And to get the final answer, just substitute the value of t, which is log sin x. So log sin x the whole square by 2 plus c is your final answer. Ta-da! Here we have to integrate 1 plus log x the whole square by x. 1 plus log x is your inner function, and its differentiation is available. So let's assume plus log x is equal to t. Differentiate both the sides. Differentiation of 1 will be 0 plus 1 by x dot dx will give us dt. So we are ready to modify our integration. This 1 plus log x will become t the whole square, and dx upon x will become dt. So we just have to integrate t square, and it will be t raised to 3 by 3 plus c. And to get the final answer, we have to put the value of t, which is 1 plus log x whole cube by 3 plus c. Ta-da! Here we have to integrate x plus 1 into x plus log x the whole square by x. Here, x plus log x is your inner function. So let's assume x plus log x is equal to t. Differentiation of x will be 1 plus differentiation of log x will be 1 by x dot dx dt. Or after taking LCM, we will get x plus 1 upon x dot dx is equal to dt, right? So here we are ready to modify our integration. Instead of x plus log x, we just have to substitute t the whole square, and x plus 1 upon x dot dx will become your dt. The integration of t square will be t raised to 2 plus 1, or we can say 3 by 3 plus c. And to get the final answer, just substitute the value of t, the whole cube by 3 plus c. Ta-da! Here we have to integrate x cube sine tan inverse x raised to 4 upon 1 plus x raised to 8. Here tan inverse x raised to 4 inner function, so let's assume is equal to t. Now differentiate both the side. You have to take box around the x raised to 4. So differentiation of tan inverse box is simply 1 upon 1 plus box square into d by dx of box. Within the box we have x raised to 4. So we just have to multiply differentiation of x raised to 4, which is 4x cubed dot dx is equal to dt. Okay, we will get x raised to 3 upon 1 plus x raised to 8 dot dx is equal to 1 upon 4 dot dt. So we are ready to modify our integration. This sine tan inverse x raised to 4 will become t, and 1 plus x raised to 8 dot dx will become 1 upon 4 dot dt. So we don't have to worry about this 1 upon 4. This is a constant term. Integration of sine t will be minus cos t plus c. Now just substitute the value of t. Cos t will become cos of x raised to 4 plus c. Is your final answer. Ta-da! Here we have to integrate x cube minus 1 whole raised to 1 by 3 into x raised to 5 dot dx. In this question, x cube minus 1 is an inner function. So let's assume that term is equal to t. Differentiate both this side, you will get 3x square minus 0 dot dx is equal to dt. Or we can say x square dot dx is equal to 1 by 3 dot dt. So we need to get this x square within the multiplication of dx, and for that we have to split x raised to 5 as x cube into x square dot dx, and rest of the terms will be as it is. We are ready to modify our integration in terms of t. This x cube minus 1 will be t raised to 1 by 3. The value of x cube can be obtained from the assumption as a t plus 1. So instead of x cube, let's place t plus 1, and x square dot dx will be 1 by 3 dot dt. Now for simplification, 1 by 3 is constant, take it outside. Let's multiply t raised to 1 by 3 with t raised to 1. We will get t raised to 1 by 3 plus 1, or we can say 4 by 3, plus t raised to 1 by 3 ones are t raised to 1 by 3 dot dt. So we are ready to integrate this 1 by 3 as it is. Integration of t raised to 4 by 3 will be t raised to 4 by 3 plus 1, or we can say 7 by 3 upon 7 by 3 plus t raised to 4 by 3 by 4 by 3 plus c. Now let's multiply 1 by 3. So we will get by 7. Just place the value of t, which is x cube minus 1 whole raised to 7. X cube minus 1 whole raised to 4 by 3 upon 4 plus c is your final answer. Ta-da! Here we have to integrate sin x upon 1 plus cos x. Here the differentiation of 1 plus cos x is available within the multiplication of dx. So let's assume 1 plus cos x as a t. Differentiate both the sides, we will get 0 plus differentiation of cos x as a minus sin x dot dx is equal to dt, or we can say sin x dot dx will be your minus dt. So here we can modify our integration as this sin x dot dx will become minus dt, and 1 upon 1 plus cos x will become 1 upon t. So we don't have to worry about this negative sign. Integration of 1 upon t is simply log mod t plus c. And to get the final answer, just substitute the value of t, which is 1 plus cos x. So minus log 1 plus cos x plus c is your final answer. Ta-da! Here we have to integrate sin x upon 1 plus cos x the whole square. Here differentiation of 1 plus cos x is available. So let's assume 1 plus cos x as a t. Differentiate both the side. Differentiation of 1 minus sin x dot dx is equal to dt, or we can say sin x dot dx is simply minus dt. So we can modify our integration as this sin x dot dx will become minus dt, and 1 upon 1 plus cos x will become t the whole square. So here we don't have to worry about this negative sign. We just have to integrate t raised to minus 2. So minus integration of t raised to minus 2 to minus 1, we can say minus 1 upon minus 1 plus c. In further simplification, minus 1, t raised to minus 1, or we can say 1 upon t, or we can say 1 upon 1 plus cos x plus c is your final answer. Ta-da!